Hello everyone, my name is Monica Madineni. This presentation is on the topic artificial intelligence. These slides are created based on reference from the below paper, that is risk assessment of additional works in railway construction investment using the Bayes network. Next slide. Yeah. Yeah, here we are going to know about a brief introduction, framework model for the risk assessment method, identification of the risk of additional works in railway project, risk analysis, Bayesian statistics, and the Bayes network method, risk evaluation, building a risk assessment matrix, summary, and conclusion. Next slide. Coming to the abstract, the execution of railroad framework development projects incorporates supportable advancement objectives and a gameable of extra work is in an after effect of various elements. The article proposes a restrictive administration strategy for listening the gamble of extra works utilizing Bayesian organization. Utilizing the case of a situation of events, it is demonstrated by the way that a very much customized organization can be utilized to execute risk mitigation methods. Utilizing the organization, it is feasible to contrast various ways with a decreased risk, which check the effect of diminishing the gamble factors and decide an acceptable degree of impacts. Example, expanded financial resources because of extra works. Next slide. Coming to introduction, quantitative and subjective exploration is lead to the decide the chance of specific occasions happening. The probability of event of a gamble relies upon the kind and size of the task, the lawful and political circumstances, and the deployment climate. An enormous EU project is being executed in Poland to modernize the railroad organization. The venture implies many dangers, including unexpected or extra work. Huge framework development projects, as indicated by feasible advancement objectives, are a mind-blogging process comprising many stages. An appropriately chosen risk, the executive's methodology can ensure a venture's fulfillment on time and inside spending plan. Risk the board in development is a broadly examined issue in the business writing. Next slide. This is a risk management process according to ISO. There is a lot of examination connected to the risk, the executives, including restrictive programming, risk ID, evaluation, and chance legitimacy assurance. A few numerical models are likewise utilized for risk appraisal. Additional works can occur as a result of many factors despite the investor's due diligence when designed a construction project. These factors include a change in the assumed design. The subject of extra works in development is seldom examined in the writing. A few scientists portray factors cause extra works, while others examine granting contracts for extra works in street speculations. This paper presents a technique of surveying risk in rail line framework development projects utilizing master interviews and Bayes network model. Next slide. Coming to framework model for the risk assessment method. As per the rules of the norm, things comprise of three progressive stages which incorporate risk identification, risk analysis, and risk evaluation. The ISO risk management principles and guidelines standard will be used as the baseline procedure for conducting a risk assessment. The ID, everything being equal, can be troublesome, yet the embraced philosophy can help risk management. Risk assessment techniques make reference to 31 strategies which are separated by their handiness. Next slide. Can you share the next slide, Vandana? Oh, no, before the, yeah. Stages of risk assessment. The picture shows the stages of the risk assessment and here the risk identification, risk analysis, and risk evaluation. In the risk identification, the structured or semi-structured interviews, and in risk analysis, Bayesian statistics and Bayesian networks, we're going to study about this. In risk evaluation, the consequences and the probabilities of the matrices have been chosen. The creators utilized the organized and semi-organized meetings to acquire input information on the issue of extra works in railroad development projects and Bayesian insights and Bayes network for risk investigation. The result or likelihood grid was utilized in the risk appraisal. To acquire input information on the issue, master information was gathered utilizing organized or semi-organized interviews. Bayes networks were utilized for demonstrating and circumstances and logic result summarizing was utilized for risk assessment. Next slide. From here, Vandana is going to continue.
Thank you, Monica. So now we'll go ahead and talk about the identification of the risks of additional work in railway projects. So the author, he developed a questionnaire with questions to enable the identification of most relevant factors, identifying emerging new rail infrastructure construction investments in Poland. So individuals with direct interviews with 5 individual and direct interviews with 5 participants in the construction process who deal with rail infrastructure constructions were done for the questionnaire that was created. So let's go and see what the questions were. So these are some of the questions that they asked, and each answer that was given was it was given as a probability of occurrence, so expressed in percentage, and the respondents were asked to assign a probability of occurrence to it. So the arithmetic mean of the acquired data was used to calculate the risk level estimated, and the arithmetic mean of the available expert replies was used to calculate the assumed risk levels. So the findings, it determined an average probability of risk factors around which was exceeding 60%, and the occurrence of type of an additional work which was exceeding 10%. So these were presented to an expert with the most seniority and experience in the implementation of railway works, which was based on the subject matter, for that particular subject, whoever was the expert. So they were asked to give us some details, who are not involved in the study. So next, let's see what happened next. So following the given standard guidelines, risk identification should include the following elements, that is determination of the risk, determination of the consequences, and of the possible determination of the possible scenarios. So the answer provided by the respondents, risks were based on that, the risks were grouped into risk related to appearance of additional work and risk related to the occurrence of individual types of additional works. So dividing them into groups, risk identification was completed once it was divided in it. So as you can see, there are risks appearances of additional work and risks that were the type of additional work based on the type of the additional work. So next, we'll be talking about the risk analysis using the Bayesian statistics and the Bayes network method. So based on the research that was done so far, author chose some factors which were rated highly to build the risk analysis model. And let's see how the model looks. So these are some of the factors that were used for risk analysis. So to create the risk model using the Bayes analysis was used. And since it is based on the probability and it allows adding new information to the model, using the knowledge or data gained through the network. So Netica software was used to build the model in forms of Bayes network. So the 4 stages used in the risk analysis were carried out are creating the nodes of the Bayes network, giving relationship to particular network, and assigning event probability, and then performing calculations. So let's go through each of these stages. So the first one is creating of nodes of the Bayes network. So the nodes of the Bayes network were created using the selected risk variables, the possibility of extra work, and the type of the additional work, and also the repercussion of this phenomena. Like there are 9 nodes in the risk and like assessment model. So based on the characteristics of the nodes, tasks were assigned to them. As you can see in the first figure, this as an example, a node defined the occurrence of inadequate work organization, that is like bad organization of work. So as well as like alternate scenarios of this risk assessment component. So individual node relationships were created using expert information gained through interviews, research, and writers' own experience. So, in the process of like analyzing the risks of like extra work, the relationship will be like used to explore like possible scenarios or the other occurrences of other events. And the event was like modeled by connecting the nodes that made up the risk factors, such as like bad work organizations, investor changes, or project document errors. So as well as the effects of the appearance of work in the form of like different types of industry works, which are like track work, engineering object work, road work, and network works. So like further calculations were like performed using the network proposed in the second figure here. So now let's go to the next step, that is assigning event probabilities. So here, like each event must be like assigned to a probability of occurrence in the order for the model to function properly. So expressed like by in the means of like a percentage scale, this model. Okay. Furthermore, the Bayes network, like it differs from other networks in that like it directly introduces the events to the beginning node of by like establishing probability levels. So the conditional probability of chain technique must be used to characterize further nodes connected by reciprocal relationship. And this necessitates the writer examining all potential sequence of events and calculating their probability. So conditional probability tables are like provided for this purpose. So as an example for the conditional probability table, you can see in the figure here. Next, let's look at the performing calculation step. So the Thomas Bayes theorem, which connects the conditional probability of two occurrences conditioning like each other, is the essential relationship employed in the deployment of the Bayesian network. So by applying this theorem in a series of events, we may like calculate the probability of all the occurrences in the network, and calculations were performed after the model was prepared. And the Netica software was used to calculate the conditional probability, and the computations provided a working network like that can be used in the next stage of risk assessment evaluation. So large network like demand complex programming, which might be difficult. So Bayes theorem is expressed in the first formula that we have here, while the conditional probability theorem is expressed in the second formula. So in this formula, the A and the B are the events, and P of B should be greater than 0. And P of A or B is the probability of events occurring, event A occurring if event B occurs. And P of A and B is the probability of common parts of event A and B. So evaluate like calculations like were performed after the model was prepared, and the conditional probabilities like were calculated with the Netica software, and the computations yield like a working network that may be applied to the next stage of risk assessment evaluation. So the figure here like shows the network after calculations along with the determined like conditional probability of occurrence. So that's it for me, guys. From here, Shumaila will be taking over.
Yeah. Hello, everyone. Now I will start from risk evaluation. So here, the author was unable to discover a method dedicated to additional works in the available literature on the subject. So the matrix method was developed to determine the risk criterion. This strategy is based on the notion that risk is expressed as the product of probability and its effects in a task. Can we go to the next slide? Yeah, so here these are two tables which show the probability ranges of events and effects. There are five intervals were offered for event probability, matching to the expected probability levels, while three intervals were given for event effects, which are connected with events that result in a longer implementation time, that consequences in the studied model. So we can see in the table that the probability from 0 to 20% is in event frequency, and it is percentages going higher. So we can see that there are unlikely, possible, and likely, and at last almost certain. So for almost certain, it's 80 to 100% probability, and the point value goes to 5. And in the next table, the second one, so there are effect of events are mentioned. So for low, it is up to 3 months, the investment duration, and for medium and high, it is going uh, greater. Like for high, it is over 6 months. Can we go to the next slide, please? Yeah, here the risk level ranges are shown with the help of this table. So a reference is expected to risk levels is required when comparing risk criteria. For the sake of the analysis, 4 degrees of risk that are low, medium, high, and very high were recommended, as well as probable event scenarios. A concept for additional risk management is included in the proposed scenario. To match the risk to the proper level, we need to enter a point range ranging from 2, which is the lowest, and we can say the rarest risk, and it is up to 50. That is the highest and most common danger. It is very high and almost in the certain risk category. The risk level ranges as well as point values and action possibilities that are described in this table. Next slide, please. So here the risk assessment with point metrics is mentioned. So the introduction of the presumed risk criteria and the impact of risk in the matrix is required for risk assessment. Point value and color were also used to describe the individual matrix cell, which we can see in with the help of this table. So the hue was chosen based on the level of risk. The risk assessment matrix is presented here in this figure. So here the low risk level is in blue color, green color is for medium risk level, and yellow color is for high risk level, and red is for is like a dangerous zone. So it's very high level of risk. Next slide, please. Event scenario analysis. So it is feasible to examine alternative levels of event information that are as probability ranges, but the others believe that declaring probability as 0% or 100% best portrays the scenarios that are possible in reality. The assignment of these values might be interpreted as a certainty of an event occurring, like at a 100% probability level, or certainty of the event not occurring at the 0% probability level. All conceivable scenarios of occurrences can be studied, or the main ones that have the largest impact on the appearance of negative, that is good impacts, can be concentrated on depending on individual needs. Next slide, please, Vandana. So here the Bayesian network in the event of faulty documentation is mentioned here. So the scenario that will be examined is the occurrence of a risk factor such as project documentation errors. So this occurrence is put at the top of the project documentation errors. In order to explore the situation in the faulty event, 100% probability was required. The consequences of an event involving the discovery of defective design documentation are depicted in this diagram. So we can see here in the gray color box, the faulty percentage is 100% and the correct one is 0% in the errors of project and project documentation block. And apart from this, the extending implementation period to 3 months is at a rate of 36, and implementation period from 3 to 6 months is a 40.7% increase, and period up to 6 months, so it's at a cost of 23.3%, which is mentioned in this figure. Now, next slide, please. So to reduce the risk and reduce the fault, there are some proposals which are mainly used. So the optimal risk management plan is determined by a number of criteria that are a list of risk hierarchies, the likelihood of meeting cost and scheduled goals, a list of viable ways of action, and so on, and involves a reaction to each type of risk in the project. So here the risk avoidance, risk transfer, risk mitigation, risk acceptance, these are most common prevalent tactics. Among all of these options, one approach of risk mitigation appears to be the most effective in the implementation of railway investment. Next slide, please. So here we will discuss about the risk mitigation. Risk mitigation is a strategy for lowering the probability of severity of a negative risk event to a manageable level. The conceivable actions according to this description include lowering the likelihood of incorrect documentation as a result of numerous activities. Next slide, please. So again, we have a Bayes network diagram. So here we can say, after applying these mitigation techniques or strategies, what we can figure out, we can see in this figure, it depicts the network model as well as the lowered risk factor of inaccurate design document. So in the gray box, errors of project documentation, we can see that faulty rate is reduced from 100% to 50, and the correct is automatically goes up to 50. So after applying the mitigation technique, this fault percentage has reduced. Next slide, please. Now we come to the conclusion part. So to conclude, I would say that the chosen scenario includes a novel technique based on primarily on the Bayes network. This method enables the creation of complicated impact networks that can be modeled using surveys, historical data, or expert opinion. These networks can be used to investigate the impact of specific event scenarios. The user can evaluate different approaches to reduce risk, examine the influence of variables generating additional works on the other tops of the network, or decide a sufficient level of effects, such as a growth in the worth of financial resources as a result of new works by using the network. So the analysis of extended structures in combination with the proposal risk mitigation strategy may become a comprehensive method for managing the risk of additional works occurring during the implementation of railway investments, which investors or railway line managers can implement and use in practice. Next slide, please. Here is the end of our presentation. Thank you so much, everyone.